Hello to everyone. In this video, let us discuss what is salt hydrolysis and how to calculate pH for different type of salts. Okay. First, let us see the definition of salt hydrolysis here. So what is that here? If you consider AB as a salt, when dissolved in water, it produces A plus is cation, B minus is anion. So like that, when a salt is dissolved in water, produces which one here? Cation and anion. And this cation is said to be which one? Conjugate acid. And anion is said to be conjugate base. So, if A plus, that means if conjugate, that means conjugate acid of this AB is stronger one, it will react with water. So, what we can get here? A plus when react with water, we get HA. Okay. What we can get here? A plus will react with OH minus. So, we get AOH plus which we can get H plus ions. That indicates what here? If cation is stronger one, it reacts with water and produces which ions here? H plus ions. Now, if B minus, if it is the stronger one, if this B minus is the stronger one, it react with water and that combine with H plus ion of water and produces HB, and here what we can get now? OH minus ions. So if anion react with water, which ions are produced means OH minus ions. So this indicates what here? If cation react with water, H plus ions are produced. If anion react with water, OH minus ions are produced. So based on that reaction, that salt solution sometimes may have an acidic nature, sometimes may have basic nature, like that. If H plus and OH minus concentrations are same, that means if both A plus and B minus of salt react with water, we get H plus and OH minus. At that time, based on the concentrations of H plus and OH minus, that nature will depends. So first one thing we have to confirm here, if cation of a salt react with water, that aqueous solution of salt having acidic nature, or inversely we can say like this also. If any salt solution, that means aqueous solution of salt is having acidic nature, that indicates cationic hydrolysis. And similarly, if any aqueous solution of a salt having basic nature, that indicates anionic hydrolysis. So if salt solution is having acidic nature, cationic hydrolysis. If salt solution, that means aqueous solution of salt having basic nature, anionic hydrolysis. If these two are weaker, therefore no reaction with water. If cation and anion both are weaker, therefore no reaction with water, means there is no production of H plus and OH minus ions. Therefore, the solution of that salt might be neutral. Okay. Now, what is the definition? Let us see here. What is the definition of salt hydrolysis? reaction of either cation or anion or both of a salt with water to give H plus or OH minus or both the ions is known as salt hydrolysis. So now if salt undergoes hydrolysis that produces acid and base, that means here we can write that reaction like this. Salt plus water gives what here? Acid plus base. So this is appearing as which one? Reverse of neutralization. So salt hydrolysis is reverse process of neutralization, because in a neutralization reaction acid react with base to give which one? Salt and water. But in this process salt reacting with water to give acid and base. So this is reverse process of neutralization. Now here different types of salts are present. What are the different types of salts? Let us see, and we have to discuss that hydrolysis of different type of salts. First type of salts are which one here? Salts of strong acid plus strong base. Salts of which one? Strong acid plus strong base. So now before going to this explanation, first let us know what are the examples of strong acids, weak acids, strong bases, weak bases, etc. So now strong acids examples means here HI, HBr, HCl, H2SO4, HNO3, H3PO4, H3PO3. These are some examples of strong acids. And examples of weak acids, especially first we have to write acetic acid and then carbonic acid, HCN, hydrogen cyanide, HF, H3PO2 and HNO2. So these are considered as which one? Weak acids. And strong bases, easy to remember, first A group hydroxides. First A group hydroxides, all are examples for strong bases. First A group hydroxides means what? Lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. Except first A group hydroxides, remaining all bases are weak bases except above. All are come under which one? Weak bases. Means second A group hydroxides. Beryllium hydroxide, calcium hydroxide, magnesium hydroxide, and transition elements hydroxides. What are those examples? Manganese hydroxide, ferric hydroxide, ferrous hydroxide, FeOH taken twice, like that. All those come under aluminum hydroxide, third A group element. All those come under weak bases. First, we should know these examples for different category, means strong and weak acids, strong and weak bases, etc. Okay, now this is very important for our topic. If you remember these examples, easily one can answer the questions from salt hydrolysis. Okay. Now let us see salts of strong acid and strong base. And example is here NaCl. This salt is formed by the combination of strong base NaOH and strong acid which one? HCl. So like that NaCl is produced. When NaCl dissolved in water, we get Na plus and Cl minus. Now come to the Cl minus. Cl minus is the conjugate base of strong HCl. That means here the conjugate base produced from strong acid is weak. We have one proverb that what is Pandita Putra Paramashunta. Like that, the base produced from strong acid is a weaker one. So as Cl minus is weak, there is no reaction with water. So no production of H plus ions, etc. anything. Now come to and OH minus also we can't get anything. Any ions are not produced here. Now Na plus water. This is also produced from which one? Strong base. So it is also weak conjugate acid. As it is a weak conjugate acid, no reaction in between H2O and Na plus. Now, when NaCl dissolved in water, there is no chance of H plus or OH minus ions in this aqueous solution. So, the solution is having neutral nature. pH value is exactly 7 and no hydrolysis takes place, either cationic or anionic. Okay, now let us go for second example. Which one here? Salts of weak acid plus strong bases. Weak acid plus strong bases. Weak acid example is which one? Acetic acid. Strong base example NaOH. So what we can get here? CH3COONA, sodium acetate. This is an example of salt produced from weak acid and strong acid. When this dissolved in water, we can get which one here? CH3COO minus and Na plus ions. When this dissolved in water, we get acetate and Na plus ions. Already we discussed this. Na plus water, no reaction. Now come to acetate ion. Acetate is the strong conjugate base produced from weak acetic acid. As acetic acid is weak, the produced conjugate base from that weak acid is a stronger one. So, acetate ions react with water and produces OH minus ions. As OH minus ions are produced here, now this solution is having basic nature and pH value is greater than 7, and this solution changes red litmus to blue litmus, and as hydrolysis is taking place, now let us write that which one here, that hydrolysis constant. Hydrolysis constant Kh is equals to Kw by Ka, where Kw is which one? Ionic product of water. Its value 10 power minus 14 by Ka. So this is formula to calculate hydrolysis constant. And to calculate its pH, what is the formula here? pH equals to 1 by 2 into P power Kw plus P power Ka plus log C. C is the concentration given for that salt. P power Ka. Ka means dissociation constant of that acid. Kw means ionic product of water. So this is the formula to calculate which one here? pH for salts of weak acid and strong bases. Okay, now let us go for another one here. Salts of strong acid and weak base. Strong acid, weak base. So one example, let us connect here. Weak base example, NH4OH is a well-known example here. HCl consider as a strong acid. Now the salt produced is NH4Cl. When dissolved in water, we get NH4 plus Cl minus. As Cl minus is weak conjugate base produced from strong HCl, no reaction with water. So no chance of OH minus ions. Now NH4 plus, it is the strong conjugate acid produced from weak NH4OH. So it reacts with water and produces NH4OH and H plus ions. As this aqueous solution having H plus ions, now this solution is having acidic nature and pH value less than 7, it changes blue litmus to red litmus. And what is the formula to calculate which one? That hydrolysis constant KH. So see the formula here. KH equals to KW by KB. Easy to remember. Which is weak in between them, the dissociation constant should be present in downward. That means in the society who are weak, they are always present in the downward. So like that, this is weak now. Now KB also present in the downward. Okay, then to calculate pH, as this pH is less than 7, so we have to write which one here? 1 by 2 into P power KW minus P power KB minus log C. KB is dissociation constant of weak base, C is concentration of the salt, and KW means you know that ionic product of water. So this is regarding which one? Salts of weak acid and strong base. And another type of salts, last type here, salts of weak acid plus weak base. So example here, acetic acid and NH4OH. From that we get ammonium acetate. On hydrolysis we get what here? Acetate ions plus NH4 plus ions. As both are produced from weak acid and weak base, both these are stronger one. So acetate ions react with water and produces acetic acid plus OH minus ions, and NH4 plus also react with water and produces NH4OH and H plus. As both OH minus and H plus ions are formed, how to determine the nature of the solution? See here. If H plus and OH minus concentrations are equal, that aqueous solution of that salt having neutral nature. If H plus concentration greater than OH minus, that solution is having acidic nature. If H plus concentration less than OH minus concentration, this solution is having basic nature. So like that we have to determine. And here, what is the formula to calculate hydrolysis constant? KH. So what is the formula to calculate KH? Equals to, as both are weak, both present in downward, means in the denominator, Ka and Kb. So now the formula is Kw by Ka into Kb. and pH calculation formula half into P power Kw plus P power Ka minus P power Kb. So this is the formula to calculate which one pH of that type of salt. And easy technique, what is the easy technique to give the nature of the salt? So one question I will give here. See what is that question. For example, they have given which one here, NaBr or NaCl consider. What is the nature of that aqueous solution question given? First we have to observe what are the forefathers of NaCl. That means from which base, which acid these are produced. So now the background powers are which one? NaOH and HCl. So that means here both are strong. NaOH is strong, HCl is strong. For example, if I think you know the Bahubali movie. If Amarendra Bahubali, Mahendra Bahubali fight each other, who will win the match means match will become draw because both are strong. Like that here, as strong acid and strong base, the match become draw. That means solution is neutral, pH value is 7. Now come to another example here. Example is what here? I can give another example here, KCN. Let us see what is the nature of this aqueous solution. We have to observe the background powers, means which acid, which base produced this KCN. What are that background forces here? KOH and HCN. We know that KOH is a strong base, HCN is a weak acid. That means if Australia and Zimbabwe play the cricket match, who will win the match means Australia, because Australia is having strong cricket team. Like that only, if strong base weak acid play the match, who will win the match means strong base. That means this solution is having basic nature, pH value is greater than 7. Just we have to observe the background powers. Okay, now I give another example. We have to observe what should be the nature of its aqueous solution. Okay, I give one example here. What is that means? MgCl2. So this salt is produced from MgOH taken twice and HCl. It is weak base because not belongs to first A group now. So weak base, this is strong acid. If strong acid, weak base play the match, who will win that match means strong acid. So now this aqueous solution is having acidic nature and pH less than 7. Blue litmus changes to which one? Red litmus. I give some another example here. For example, if you consider ZnCl2, this is the mixture of or produced from ZnOH taken twice and HCl. It is strong acid, ZnOH taken twice is weak base. So that solution is having which nature means acidic nature. Like that we have to give the answer for nature of aqueous solutions of any salt. Okay, bye.